Have you ever wondered how the Earth's magnetic poles affect our climate? It's a question that has perplexed scientists for many years. Today we're going to embark on an enlightening journey to explore this fascinating phenomenon. Welcome back to Random Realm. I'm Jessica. Buckle up for an electrifying ride through the mysteries of our planet. The Earth's magnetic poles, their mysterious shifts and reversals, and most importantly, how they influence our climate. This is more than just an inquisitive dive into geophysics. It's about understanding the intricate invisible forces that shape our world and impact our everyday lives. We'll unravel the complex relationship between the Earth's magnetic field and our climate system, a topic that continues to stimulate research and debate in the scientific community. We'll also delve into the fascinating history of magnetic pole reversals and what they can tell us about the future of our planet. As we delve deeper into this topic, prepare to have your mind expanded by the wonders of our planet's magnetosphere. To understand how Earth's magnetic poles influence climate, we first need to understand what these poles are and how they work. Earth's magnetic poles are not static, rather they are dynamic and ever-changing. They're generated by a fascinating phenomenon known as the geodynamo. Imagine a spinning sphere of molten iron and nickel in the Earth's outer core. As this sphere rotates, it creates electric currents, which in turn generate magnetic fields. These magnetic fields align approximately with the Earth's rotation axis, giving rise to the north and south magnetic poles. However, these poles don't exactly match the geographic poles and they're not stationary. Over time, they wander. Yes, you heard it right, they wander. This is due to the fluctuations in the flow of molten iron within the outer core. This wandering of the magnetic poles is known as geomagnetic secular variation. Now, let's talk about something even more interesting: geomagnetic reversals. These are events where the north and south magnetic poles switch places. Sounds like science fiction, doesn't it? But it's very real. Over the course of Earth's history, these reversals have occurred numerous times, roughly every few 100,000 years. The last reversal happened about 780,000 years ago, so we're not due for another one just yet. It's important to note that these reversals don't happen overnight. They are slow processes that occur over thousands of years. During a reversal, the magnetic field doesn't vanish. It just gets complex and multipolar until it settles again. So why does this matter? Well, Earth's magnetic field plays a crucial role in protecting our planet. It shields us from harmful solar radiation, and without it, life as we know it wouldn't exist. Now that we have laid the groundwork, we can explore how these shifting poles impact our climate. The Earth's magnetic poles are not fixed, they wander. This is known as geomagnetic secular variation. Now, this might sound a bit unnerving, but don't worry, we're not drifting off into space. The process of pole shifting is a slow and gradual one. It's like the hands of a clock, moving so slowly that we don't notice it in our daily lives. Over centuries, however, these changes can be significant. And it's not just a simple north to south shift. The magnetic poles can wander in various directions and even flip completely in what is known as a geomagnetic reversal. So how do we know all this? Well, the evidence is etched in the geological record. Ancient lava flows are particularly informative. As they cool and solidify, they lock in a record of the Earth's magnetic field at that time. By studying these natural archives, scientists have discovered that the Earth's magnetic field has reversed hundreds of times in our planet's history. The last reversal, known as the Brunhes-Matuyama reversal, occurred approximately 780,000 years ago. But what about the current status of the poles? Well, the North Magnetic Pole is on the move. It's been drifting from the Canadian Arctic towards Russia at a rate of about 35 miles per year. The South Magnetic Pole is also shifting, although at a slower pace. Now, I know what you're thinking. Are we due for another big flip? Well, it's hard to say. These reversals are irregular and unpredictable. Some scientists believe we might be in the early stages of a pole reversal right now. But before you start rearranging your compass collection, remember that these shifts happen over geological timescales. We're talking thousands to millions of years. So while the wandering poles might not affect your weekend plans, they play a crucial role in our planet's history and future. They're part of a dynamic and ever-evolving system that shapes our world in ways we're still uncovering. With this understanding of pole shifting, we're ready to dive into its effects on our climate. The Earth's magnetic field plays a vital role in our climate, and changes to this field can have significant effects. Let's dive into the intriguing relationship between our planet's magnetic field and the climate. This invisible field, generated by the churning of molten iron within Earth's outer core, acts as a protective shield against a barrage of solar radiation. These energetic particles, if not for our magnetic field, could wreak havoc on our atmosphere and consequently the climate. Consider the magnetic field as Earth's sunscreen. It deflects a substantial portion of the sun's harmful solar wind, a stream of charged particles ejected from the sun's surface. Without this magnetic sunscreen, the solar wind would strip away our atmosphere, leaving Earth exposed to intense solar radiation. This could drastically heat up the planet, making life as we know it impossible. The magnetic field also influences atmospheric circulation, the large-scale movement of air that helps distribute thermal energy around the globe. It does this by affecting the ionosphere, an atmospheric layer charged by solar radiation. Changes in the magnetic field can modify the ionosphere's electrical properties, which in turn can influence atmospheric circulation patterns, potentially leading to changes in weather and climate. For instance, during periods of intense solar activity, the increased solar wind can compress the Earth's magnetic field, causing it to fluctuate. These fluctuations can generate electric currents in the ionosphere, altering atmospheric circulation and potentially triggering shifts in weather patterns. Moreover, Earth's magnetic field might even play a role in long-term climate phenomena like ice ages. Some scientists propose that magnetic pole reversals, where the north and south magnetic poles switch places, could be linked to these drastic climate shifts. The theory suggests that during a pole reversal, the magnetic field weakens, allowing more solar radiation to reach the Earth's surface and potentially contributing to global warming. However, it's crucial to note that while these theories are compelling, they are still under intense scrutiny and research. The relationship between the Earth's magnetic field and climate is complex and not fully understood. There are many factors at play, and isolating the effects of the magnetic field is a challenging task. For example, it's still unclear how significant the magnetic field's influence is compared to other factors like greenhouse gas concentrations, volcanic activity, and variations in Earth's orbit. Also, the exact mechanisms by which the magnetic field could affect atmospheric circulation and weather patterns remain a subject of ongoing research. Despite these uncertainties, it's clear that the Earth's magnetic field does play a role, however subtle or indirect, in shaping our planet's climate. It's a testament to the intricate and interwoven systems that make up our world, where changes in one area can ripple out to affect others in unexpected ways. The correlation between Earth's magnetic field and climate is a fascinating area of research that continues to captivate scientists. Today, we've journeyed through the Earth's magnetosphere, exploring its poles, their shifting patterns, and their influence on our climate. We've learned that our planet is much like a giant magnet, with a magnetic field generated by electric currents in the molten iron core. This magnetic field extends from the Earth's inner core to where it meets the solar wind, a stream of charged particles emanating from the sun. We've discovered that the Earth's magnetic poles aren't fixed. They wander, and over vast geological timescales, they even swap places in an event known as a geomagnetic reversal. This is not a sudden flip, but a gradual process that occurs over hundreds of thousands of years. The last reversal, the Brunhes-Matuyama, happened approximately 780,000 years ago. This magnetic field, this protective shield, is not just a curiosity for scientists. It has a profound influence on our planet's climate. It helps to maintain the balance of our atmosphere, protecting it from solar wind. Without our magnetic field, the solar wind could strip away the ozone layer, which shields us from harmful ultraviolet radiation. We've also delved into how changes in the Earth's magnetic field could potentially influence climate. While the exact mechanisms are still a subject of ongoing research, some scientists suggest that shifts in the magnetic field could affect the distribution of solar radiation on the Earth's surface, influencing atmospheric circulation patterns and, consequently, climate. In conclusion, the Earth's magnetic field, its poles, and their shifting patterns are not just fascinating scientific phenomena. They are vital elements in the complex system that allows life to thrive on our planet. They protect us from solar radiation, help maintain our atmosphere, and may even influence our climate. As we continue to study and understand these complex processes, we come to appreciate even more the intricate balance that makes life on Earth possible. As always, thank you for joining me on Random Realm. If you enjoyed this journey through Earth's mysteries, don't forget to hit that like button, subscribe for more mind-blowing content, and ring that notification bell to stay updated. Until next time, stay curious and keep exploring the wonders of our incredible planet. See you in the next video.
It's London Lee.